Hi there, my name's Jordan Hasty. I'm currently a researcher with the SURE 2020 program with the Limnology project. Today I'm going to be showing you how to compile our raw temperature sensor data from our two reservoirs into an hourly aggregate and a daily average value spreadsheet. So the first thing that we're going to want to do is in our OneDrive Limnology project, we're going to want to find a few files. The first one's going to be a daily average computation file, generally in the data analysis tab. You'll download that, and so this will be the file that will be our key tool to take all of our sensor data and turn it into one single compiled source. Today as an example, I'm going to be working with the Hard Labor Creek Reservoir, and I'll go to the raw temp nutrient data, and then I'll go to the most recent data entry. Normally today I'm going to go ahead and use this 25,517 data as an example. All I really want today is the temp sensors, so I'll download that. And then the last thing I want is my two aggregate files. So if I go back to aggregate data for this reservoir and I go to my current year daily average temperature and hourly aggregate, I can go ahead and download those as well. So once I have all those, I find it's helpful to go ahead and throw them into a folder. I've already put them into a folder here on my desktop. The first thing you might do is go ahead and open up one of your temp sensors, or you can open up all of them by highlighting, right-clicking, and opening them with that function. Once you see one of these open, we can start to look at what does our raw data look like. So for each of our sensors, so this for example is the 4-meter depth sensor for Hard Labor Creek Reservoir, we have an index column which is pretty much useless. There's a date time column as well as a temperature column. So what this is saying is that every 2 hours, we can see here, it records a temperature at that depth. So at 2 p.m., at 4 p.m., at 6 p.m., and so on. The reason that this date starts so weird is because that was the last time someone came out to the reservoir, so they boated out to the reservoir temperature sensor array, and they took the data off, so they might have cleared everything before that. We can also see if we go to the bottom of our of this file using a shortcut Control down arrow, which is a lot better than scrolling because there are 3,000 entries. We can see that our last data observation was on 5/17 at 10 a.m. So this just means that sometime after 10 a.m. our researchers boated out to the temperature sensor array, they took the data off of it, and this was the last observation it recorded. So there are another couple tabs with some random info. It's interesting to look through, but you don't need it right now necessarily. What we can look at now is, let's go ahead and look at what are we trying to do with this. So what we're trying to do, I'll go back to our two aggregate files. If I open those up, what's going to happen? So the first one that we're in is our hourly aggregate. We're trying to make a table sort of like this, where we have a date time column that has all of the possible observations, so every 2-hour increment. We have a shortened date column, which just has the day of it, and we don't worry about time. And then we have 10 columns of depth, so 1 meter, 2 meter, and so on, with all of our temperature readings at each of these hourly observation opportunities. You will see that there are some blanks in here. These are times where a sensor was broken, a battery died, or it malfunctioned, and we didn't get an observation for that time. We can also see in our daily average temperature file, our end goal with this is really to make a heat map, so something that looks like this. We also want to, but to do this, we have to compile it in a single source. So go Control up arrow takes me to the top of the data. Kind of doesn't work so well when there's frozen rows, but we see here that for 1/1, so January 1st, we have 10 meters of observations, and those dates without any data have no data in them. This is helpful for whenever we try and make a heat map, and we can gray these no data cells out just to show that there was no data collected for that. So this is our end goal. To get to this end goal, however, we can go ahead and exit out of those. We have to use this daily average computation Excel file. So once this loads up, this will be our main tool to kind of take those temperature sensors we pulled up at the beginning. There's 10 different of those files, and we want to put them all in one place. So here we see on our hourly tab to start off with, we're going to create a table sort of like hourly aggregate that we saw earlier with a date time, a date, and then 10 meters of observations. And the way we're going to do that is with the use of some formulas that we see here. The formula we're using is going to be called VLOOKUP. We'll see how that works in action later. Something else helpful to see is our last collection HLCR sheet. Within each Excel, so a little bit about Excel, within each Excel file is called a workbook, and then within each workbook, so this is the daily average computation workbook, are Excel sheets, and so these are the sheets running across the bottom here. In our last collection sheet here, we can see that the last time someone did what we're doing today of making these aggregate files was on 4/26. They didn't put a daily average value for 4/26 because they only have midnight to 10 a.m. and so it would be a little misleading and inaccurate to create a daily average value. We have the other half of those of like 4/26 data from noon to midnight in our new data, and so we'll create an average today. The way that we do that is once we have all of our temperature sensor arrays open, so we see them here, we can highlight them all, right click, and press open. I'm only going to open one as an example, but if you do all of them at once, it may take just a little bit for it to load. So for example, if we use our 4 meter, the steps that we're going to take for each one of these 10 files is first to rename this data sheet as 4, because that's the depth we're working with. We can right click on this sheet, move or copy. This is going to ask which book we want to do, and like we said, we want to work in the daily average computation workbook. And then we get to pick which sheet we want to put it before. So we want to put it in between this hourly and last collection sheet. So we'll click that one, okay. Now we can see in our daily average computation workbook, we now have a new sheet that we've added, which is this 4 meter depth in between hourly and last collection. So now you can go ahead and do that for all of the other 10 sensors. Alrighty, now that we have our 10 sensors all added into this daily average computation workbook, we can start to put everything together. Something that might be helpful first is to go through each of these different sheets and kind of inspect them a little bit. Look at the first and last data entry, just kind of get familiar with it. Make sure that you have data points for all your observations. So make sure that they all end around 5:17, 10 a.m. or so. I've already done this, and something that I have noticed is that our 5 meter depth actually stopped collecting in 2019, so a while back. What we're going to want to do there is make sure that we don't get false data or inaccurate data. So what this VLOOKUP function that we've been talking about is going to use over here, this VLOOKUP function, it uses an approximate measure, and so it's going to try and find the date that's closest to this over here as our selection. Basically what it's going to do is it's going to grab the 7470 and it's going to repeat it over and over and over again for all of our missing dates. What we can do here to remedy this a little bit is if we highlight 2 cells and then fill it one more down below, now we have a data observation that's 2 hours afterwards, and then put 0 here. Later on, whenever we use our functions, we're going to see a whole bunch of repeated zeros, and this will help us identify where we need to remove what data is not actually real. What we can do now is, if we remember we want to create a list of observations over here for all possible opportunities, the way we can do that is we can start by using the last collection, highlight this column here, which was the last observation that we have recorded. We'll place this into cell A2, and now we can go to one of our sensors that collected data all the way to the end, highlight this last observation, we'll paste it down here. Now we can go ahead and use our fill function to create a series down starting at this date and ending at this date for every 2-hour observation. The way we'll do that is first to recognize that Excel records all dates as numbers fundamentally, so we can change the format here to a number. So this date of 5/17 is actually recorded as this long number here. Something else we can do is we can see what 2 hours represented as a number is. We can do that by just typing equals 2 divided by 24 and then adding a couple more decimal places on it. So 2 hours is represented as 0.083333. Now what we can do to create the fill, we'll use this fill function up here to create a series. We'll want to make our series in columns because it's going down. Type is linear. Our step value, or how much it goes down from row 2 to row 3, row 4, row 5, and so on, will be this 2-hour increment. So we'll write 0.083333. I write about 7 threes. And then our stop value will be this last date here. So 43968.42. We'll click OK, and now we can see that we've generated a whole series. If we definitely want to put this in a format that we're more used to seeing and that's more intuitive for us. So we can go back up to this format, more number formats, and then use a date that has date and time. Perfect, now that we can see that again. Now we're going to go over here to our formula. So this is a formula key that has been recorded. It has all of our formulas stored. We can go ahead and copy them over. And this is just sort of like a guide to show you where you want to copy them and paste them over here. So we'll start in this B2, right click and just copy values is fine. Now we can see that each of these functions starts with a hashtag. Normally in Excel, to start a function, you use the equal sign to tell Excel that it is a formula. We've added hashtags just to turn them off. That's because the VLOOKUP function uses a reference right here. This 1 references this sheet here, 1, and whenever we delete this, it messes up all the functions. They'll all pop a reference error. To remedy this though, it's really easy. All you have to do is use Control F, and we're going to find and replace all of the hashtags with equal signs. We'll replace all, and I do want to note you only want to do it over these 10 cells here. We'll delete that. Now we can go ahead and highlight these 10 here and use this fill button down here. Whenever you see the black cross, you can double click and it fills down our functions all the way down. So now let's try and understand what each of these functions are doing a little bit. This first one, floor, just as a rounding. So as this date is recorded as a number, it's rounding cell A3 down to the significance of 1, and so this just makes it a smaller date. So instead of 426 and time, it's only 426. With Excel functions, you can see in this parentheses down here what arguments we're talking about. So this first one's the number, it's telling you what cell you want. If we look at this function here, it's a little bit more complex, and if you want to understand it better, I encourage you to just Google some of these functions such as VLOOKUP and IFER. The basic premise of it though is this VLOOKUP, we can see here the arguments for it. So it's looking up the value of cell A3, which is here, in the table array, or where it's looking up. It's looking it up in sheet 1 from column B to C, and then it's returning column number 2. So what does that look like? That looks like, we'll escape out of this function. That looks like in the table array of 1 between column B and C, it's looking for 426 or 516, and then it's returning from B to C, it's returning that second column, which is our temperature here. Now if we look a little closer, there are a couple other things. So this true just shows that it's an approximate because it's not looking necessarily for the exact, because sometimes one sensor may be put a little differently where it's recording on the odd hour instead of the even hour, and we still want it to get as close as possible. The only problem with that, if you're not looking for an exact match though, is you have chances such as this. Remember in sheet 5 where we ended at 9/19, 2019? This is much farther away from 42620, but however it's looking for the best or the closest possible match to 426 and to all of these options here, which is this 0 which we recorded. So what we can always do here is just highlight them all and then clear contents. The last part of the function, if error, we told it that if there's an error, we want it to, we can see here, the if error function, it uses the value of this VLOOKUP function, and if there's an error in that, so for example in 9 we don't have a reading at noon, it'll just return an empty string or an empty character, which is represented by these 2 quotation marks. Now that we have an hourly aggregate, we're going to want to create a daily average value, so a daily average value for each of our days. The first thing that we're going to want to do is finish this 426 data because we have from noon to midnight or so, and we have the data previously up here. And the way we can add this back in is just highlight it, copy, and then if we right click on column 3, we can insert the copied cells. It might take a little bit to do so. We can now see here that our 426 data has been properly inserted, and we now have a full days of data for 426 from midnight down to midnight the next night. We do want to go ahead and take away the data then at the bottom for 517, as that's a partial day and we don't want to compute an average for that. We'll go ahead and wait until our next collection date, so in a month or so. What we can do first is, you can go ahead and just paste this down here for now before we delete this. Something to note though is that you definitely want to make sure that you right click and paste values. If you just use Control V, or sometimes if you use like Control Formula for something, while these two may look the same, if you click on them you can see that these cells up here have a value in them in the formula bar. It is just that number, whereas down here these are technically formulas and they're only displaying what the formula gets once it's computed. The problem with that is because this uses the sheet 1 down here as a reference. At the end of this, whenever we clean up this workspace, we're going to get rid of these 10 sheets because we won't need them anymore, and we need to prepare it for the next month's researcher to add new 10 sheets like we did today, and so all of these values will become errors and we won't have them. So we can go ahead, clear contents here. We'll get rid of this 426 data because we already put it into our spreadsheet, and so we know that we have it. And I'll just go ahead and move that up here. We're now ready to compute a daily average value. We can do that in this daily column, or this daily sheet. The two things we're going to need are a start date and an end date. So back on this hourly, we'll get rid of this because we don't want to compute an average for it. We know that our last date is 5/16 and our first date is 4/26. So we can just write 4/26/2020 here. And then I find it's easiest just to use the fill button down here and drag down to 5/16. Highlight all of these. So these each have another formula in them. What they're doing is they're creating an average based on values inside our hourly tab. You can see here the range they're using is hourly B to B. So for one column, you can see in 1B they're using this value here, so 426, and then it's computing an average based on hourly C. So you can look around that a little closer if you want to investigate it more. All we need to do here is fill down. Perfect. Alright, we'll go ahead and save this just in case. Now what we can do is put this new data that we've just derived, our aggregate and our daily average value, and place them into our aggregate files. So if we open back up our hourly aggregate, for example, we can show this here, and it ended on 4/26 of last month. So we're going to want to put in all of our new data. What we can do here is you can always just select in one of the corners, scroll all the way to the other side. Oops, sorry, we're in the hourly aggregate. Here we go. So since we've already selected here, if we were to scroll, whoopsies, all the way down to the bottom, we can just hold down the shift button and click in this corner, and it automatically highlights them all for us. So we'll copy it, go back to your hourly aggregate, and at the bottom, go ahead and just paste this. And again, you'll want to paste the values and not the formulas. So now that that's been added, we'll get rid of this. Back to our daily average computation file, we can go to our daily column and highlight all of this new data we've computed, copy it, and add it to our daily average temperature file. So down here, whoops, it's already been added, but hypothetically it would be empty here, and you would just paste right there. Perfect, so that's how you do those. The steps you want to do now is save this to, delete it, or exit out of it, you might say. And now we're going to want to clean up this file, this daily average computation file, so it's ready for the next month's researcher. So in our last collection, we want to make sure that we have our 5/17 data, so the next month's people are ready. Now we can just go ahead and multi-select all of these sheets down here by holding down Control and clicking. You can go ahead and delete them all. Now we'll go back to our hourly tab. You can see here that now all of these cells are empty. Their formulas have a reference error because before they were trying to pull, so this would be trying to pull from sheet 2, but sheet 2 no longer exists, and so it's pulling a reference. What we can do to clean this out is use this button up here in the corner to select the entire sheet, and then deselect row 1 and row 2 by holding down the control button and clicking those two rows, I should say. Right click, clear contents, and do the same thing in the daily. So hold down control and deselect the top 2 rows and clear contents. Now we can go ahead and save this one as well and exit out. What you'll want to do now is go back to your Limno project drive, and you're going to want to replace all of these files. So for example, our daily average computation file, the file we're working out of, we can see here, we want to go ahead and replace this. So we can just drag and drop it in here. It's going to upload. It already exists, and we want to replace it. Perfect, and now we can go ahead and do the same thing in our Hard Labor Creek Reservoir, both in the aggregate data files. One additional step you'll probably want to take with one of your files, we can go back to we're working in this one, our daily average temperature. We'll want to update this heat map that we've created. I forgot that little step. So we have this heat map over here, and it's all the way out to our last date, which was 4/25, and so we can use all this data that we just got. We can copy it again, go to the heat map tab, and since we already have these rows here are 365, 366 rows across so that we have enough for an entire year. So all we have to do is go to 4/26, right click in it, what would be 4/26. You can also zoom in a little bit. It's already been highlighted for us, and we can paste special, and we're going to use the transpose function. The transpose function flips our rows and columns. And we can see here now that the conditional formatting already took place, and it went ahead and updated it with colors, which looks beautiful. The transpose function, just so you know, what it does is it takes this row and makes it into the it takes this column and makes it into the first row and vice versa. So we can see here that whereas before we had date in this column, we now have our depth, and then each one of these along the top is a date. The one other additional thing you want to do is now that we've completed the month of April, we can find the month of April using the arrow keys, and then you can use the down arrow to go all the way down. I like to go ahead and highlight this cell to show that's the end of the month, and then click on it, drag it all the way until I reach March, merge and center, and then type the abbreviation for that month. Now next month in June or July, whenever we get our next data, we'll go ahead and add another thing here for the month of May. That's how you would do a heat map if you're just updating one. If for some reason you have to recreate a heat map in Excel, so say this got deleted or you're at a new year and you have to create a whole new heat map, the process would look something like this. And this will also demonstrate what the processes, what processes are at work to make the heat map that we're working with. If we were to copy and paste all of this data, so we copy it first, and then in our new heat map, we can right click here and do that same transpose paste. Now that we have this, we can rename this column A to be depth, because now going down it's depth in meters. You're also going to want to resize all of these columns. So go ahead and drag and highlight. We want to go ahead and do it for the entire year. So while we have data out to May or so now, we want to go ahead and go 366 columns over. So just in case there's a leap year. The way you can see that is this number right about here that's crawling over. It's currently about, there we go. So it's that X366C, that shows you what column you're on. Right click on any of these column heads and resize column width. Use 0.25. And that instantly resizes everything. Now we're going to apply some conditional formatting to make our heat map. What we can do is start in this cell B2. You can see it in the corner up here. So we'll start in B2, drag all the way over. You're going to want to cover column ND and NE, as well as go a few down, because we're going to add a min, a max, and a legend. Our conditional formatting, we're going to create a couple new rules. So we'll go to Manage Rules, Our first new rule is going to be our color scale for the heat map itself. We want this format to format all cells based on their values, a 3-color scale. We'll do a number, the lowest, which will be 40. That's because most of our heat maps so far that we've ever seen have always gone from about 40 degrees to 90 degrees, but your min and max will also be able to show you this to verify that that's right. Our maximum will be the number 90 for 90 degrees, and we'll make that red. We'll also add a new rule. This rule will be format only cells that contain, so this is the rule type option up here, and we want to format only cells with specific text of no data to demonstrate which cells we don't have an observation for. We're going to change the format. We want our font and fill to be the same color, so we'll do a light gray and then do a fill of a light gray. Click OK, and then we can hit OK as well. So now this is updated. We see that our no data cells are all light gray, and then we've made a heat map out of these others. Now what we can do is we can go ahead and create a legend. We're going to call this legend temperature in Fahrenheit. We're going to want to showcase what the colors would be from 90 to 40, and we can do that by 5s. So we'll type 90 and 85, highlight both of them, and then use the fill. That's going to show Excel that we're doing a pattern decreasing by 5. And then finally, we can do a max and a min. So we'll call this max, call this min, and our function is going to equal max of everything from, whoops, we can go ahead and select A2. And then if we go one more, we can play around with that a little bit. Okay, we'll hit enter. And our min then will be equal to the min of this plot as well. Whoops, I went over just a little bit too far. There we go. So we can see up here in our formula that it's B2 to NC11. Hit enter. We also see that our conditional formatting didn't apply to this one, so we can change these rules a little bit under conditional formatting. Manage rules, we'll use this worksheet. And then you can always just use Control plus a select, and that'll add that to our selection. Click enter. Okay. And now you can see that it's updated to the same color scale as we have here. If we look at this visually, it doesn't quite seem right. It looks like we have a lot of yellow, where we would think that in December and January over here we would have more blue, and you can see here that blue makes up a relatively small scale, small portion of this. So something else we can do is, let's look at our rules again. If we look at manage rules and then edit this rule, we see that this midpoint is the 50 percentile. That may differ depending on what our data actually looks like. So if we want that to be specifically right in the middle, we can do a number, and the difference between 40 and 90 is 50, so the middle would be 25, and 25 plus 40 is 65. If we click OK and apply, we can see that our numbers change significantly. So now we see that this cool period here is reflected in our data. The last thing we want to do is go ahead and add months so that it's more intuitive and understandable. What I think is the most helpful is if you go up here in their date column and then use your arrow keys to find the end of each month, then use your down arrow to go all the way down to the bottom and fill a cell with yellow. Then what you can do is, I'll do one more. You can go through and see this yellow that's highlighted, click on it more easily, and go all the way to the end of the data, merge and center, and then type your month. So we could do that again for, say, February, merge and center for March, and then just type quickly February tab, March tab, and then we could continue to do that. So this is how you would make a heat map from scratch as well.